Hello everybody! We have arrived at the end of our journey towards understanding the ISO 12215 standard and learning how to apply it to a particular boat. In this journey, we have first studied the structure definition process. This includes two main stages. First, the design of the structure. This stage includes defining the type of structure, the elements that are considered, for instance longitudinals, floors, bulkheads or frames, and determine the position of these elements. The second stage is the Scantling calculation itself. This consists of establishing the thicknesses of the plates and section modulus and geometric characteristics of the stiffeners, so that the structure could withstand the design pressures. After this, we have talked about the different loads acting on a sailing yacht. These are mainly global loads, local loads, punctual loads caused by the yacht elements, such as appendages or rig, and finally, specific loads depending on the type of hull. I'm referring to monohulls or multi-hulls. After that, we went on by understanding the types of structures, which are transverse, longitudinal or mixed, and by studying the different elements that are considered in the structure, including union elements. We have also studied the prerequisites that are needed in order to compute the Scantling according to the ISO 12215 norm, which include information about the hull, the purpose of the craft, the design category or the type of hull. Maybe the most important part of our theoretical introduction is the explanations about the norm. In this chapter, we have explained the process followed to obtain the design pressures, which are used to determine the design shear force and the bending moments. Also in this chapter, the obtention of design stresses, which depend on the mechanical properties of the material, has been presented. Finally, we have spoken about the analysis of the results, a very important step in order to verify that the maximum stresses occurring in the resulting structure are actually below the maximum admissible values, which are precisely the design pressures. For those students not familiar with the science of strength of the materials, we have made a brief overview on the basic concepts of the science so that everybody could face the course with a proper background.
Once the theory of composite materials and structures has been introduced and the details of the ISO 12215 norm broken down, it is time to put into practice what we have learned. We have gone through the computation of the physical and mechanical properties of a composite panel, and we have applied it to compute by hand the characteristics of a bottom panel, being able to define it completely. We have dived into the SCT software, a tool that allows us to carry out the structure design and analysis quickly for the whole vessel. We have defined several types of laminates and stiffeners for the different areas of a sailing yacht. For every element generated, we have carried out the analysis, discussing the different alternatives and suggesting possible options to be followed by the present and future designers. Besides, we have included an extensive analysis of additional elements of the sailing yacht, such as the rudder, the rigging, and the keel. For these, we have considered several parts of the ISO norm and we have referred to additional documentation as well. Summing up all these contributions, we have at the end of the day the necessary tools to fully define and design the Scantling of our desired sailing yacht.